We need to find the equations of the tangent line to the curve at x equals -1. So in order to find the equation of the tangent line, I need to find the derivative. So that's my first step. I'm going to go ahead and find the derivative. So I'm going to start with implicit differentiation. So derivative of x squared is 2x. I'm going to have to use the product rule here because I have a product. You can do this two ways. I can either make this into a plus and make the x a negative, or you can put the minus and then distribute. So I'm just going to go ahead and make the x a negative x. So v is y. So derivative of u is -1. The derivative of v is y prime. So we're going to have the derivative of u times v plus the derivative of v times u. And now we're going to take the derivative of y squared. So the derivative of y squared would be 2y times the derivative of y. And the derivative of 7 is 0. So anything that has a y prime, I'm going to leave on the left. So I'm actually going to factor a y prime 2. And then these two, I'm going to move to the right. So I'm going to subtract 2x, and I'm going to add y. So then I'm going to divide by -x plus 2y. So here's my derivative. The problem that I have is, in order to find the slope of the tangent line at x equals to -1, I need both an x and a y, and I'm only given an x. So what I'm going to do is I'm going to solve for y first. So in order to solve for y, wherever I see an x in my original equation, I'm going to put a -1. So we're going to have -1 squared plus y squared equals to 7. So I'm just going to change the direction. So I'm going to subtract 7 from both sides. So I'm going to have -6. If I factor, I have, because I'm trying to solve for x or for y, I'm going to have plus 3 y minus 2. So I'm actually going to get two y values. The first one is going to be at -3. The second one is going to be at 2. So I'm going to have two tangent lines at the curve at x equals -1. So let's find the slope or the tangent line at the point -1, -3. So I'm going to substitute this into my equation. So to find the slope, I'm going to go ahead and substitute x and y into my derivative formula and solve for the derivative. So I end up with 1/5 as my slope. To find the tangent line, I'm going to write it in point slope form using the point -1, -3, and 1/5. So one of my tangent lines is going to be y plus 3 equals 1/5 x plus 1. So now I'm going to use the point -1, 2. So same way, I'm going to find my slope, and it's being 4/5. So my tangent line is y minus 2 equals 4/5 x plus 1. Part B is asking us to find where the tangent line is vertical. So where the tangent line is vertical, that means that my slope does not exist, or the derivative does not exist, because the slope of a vertical line is not going to exist. So if I look at my derivative, the time it's not going to exist is when the denominator is equal to 0. So I'm going to set the denominator equals to 0, solve for x, and I get x equals to y. The reason I solve for x and not y, because I'm going to end up with a fraction as I solve for y, and I don't want to deal with fractions. This doesn't give me the actual x coordinate. This just gives me that at x equals to y, that is when the line is going to be the tangent line is going to be vertical. So what I have to do is I have to substitute this x back into my original equation. So everywhere I see an x, I'm going to substitute it to y. And what I'm going to do is I'm going to go ahead and solve for y. So the y, and I forgot my square here, should be y squared So my y is going to be the square root of 7 over 3. So now to get x, I know that x is equal to 2y, so x is going to be 2 times the square root of 7 over 3. So that is where it's going to occur. 2 square root of 7 over the square root of 3. So at that point, the x-coordinate or the tangent line is going to be vertical at x equals 2 square root of 7 over 3.